Hello, I am Jung studying Artificial Intelligence at the PRML Lab in the Department of Artificial Intelligence at Korea University. So my research is, I'll be discussing an intriguing phenomenon observed in large language models, or LLMs, the issue of hallucinations. Now, when I say hallucinations, I'm referring to instances where these models provide plausible sounding, yet factually incorrect responses. So the primary goal is of my research is to identify these hallucinatory responses, especially the ones that contain factual errors. The importance of this endeavor is clear. By reducing misinformation, we can ensure that users of these models receive accurate and reliable information. So why is this research crucial? Firstly, these hallucinations are of concern because they're fluent and they seem convincing, which can mislead users, sometimes even leading to harmful outcomes, as highlighted in a study by C et al. In 2023. Moreover, my research proposes a unique approach to detect such hallucinations, where instead of the traditional models, I'm proposing the use of pre-trained language models fine-tuned on synthetic data. But there's a catch, and there are significant costs associated with this method, as found in the study by Zhu et al. In 2021. And interesting, while most studies focus on identifying hallucinations by looking at the output response, my approach is slightly different, where we aim to delve deeper into the internal model symptoms. To give you a visual understanding, consider this scenario where we feed the LLM with a prompt about the colors of apples and bananas. A hallucinating model might assert that apples are red and bananas are blue, a clearly false response. With the plug-and-play structure I propose, we can evaluate this response and determine its confidence. The high confidence for correct facts and low confidence for hallucinations, enabling users to discern the accuracy of the information they receive. In the following slides, I'll delve deeper into the key papers that have influenced this research and pave the way for my approach. These papers offer invaluable insights into the challenges and potential solutions in detecting hallucinated content in neural sequence generation. So the first paper I'm trying to introduce is called The Internal State of an LLM, knows when it's lying, by A. Azaria and colleagues in 2023, which explores the fascinating idea that the inner workings of an LLM might hold the key to discerning its truthfulness. So the primary objective of this paper was to harness the hidden layer activations of an LLM to predict the veracity of its generated statements. To achieve this, the researchers introduced the statement accuracy prediction method, or SAPLMA for short. They developed a true-false dataset with reliable sources and the aid of the infamous ChatGPT. Well, their hypothesis, which aligns closely with my research, suggests that the hidden layers of an LLM contain vital information about the truthfulness of a statement. Their experiments spanned 5 different hidden layers, shedding light on the depth at which these truths might reside. Now, onto the results, which are truly remarkable. SAPLMA not only outperformed baseline models in accuracy, but showed intriguing patterns where the most likely, the middle layers surprisingly were more accurate than the last layer, which was mainly tasked with generating the next token. So the last layer was not the one with the most information, but rather it was only focusing on generating the token right after. Well, the chart on the right visually represents the accuracy of each hidden layer across various topics. As we can observe, there's a distinct pattern that emerges, underscoring the potential of this approach. In essence, this study showcases the untapped potential of the inner layers of a LLM and their capacity to act as truth detectors. This insight was crucial in shaping my research direction and methodology. Moving forward, I'd like to introduce you to another seminal work that greatly influenced my research trajectory. This research, conducted by N. Lee and her team, I think, in 2022, focuses on enhancing the factuality of language models during open-ended text generation. The core objective of this study is quite similar to the previous one, leveraging the hidden layer activations of a large language model. However, the focus here is to predict and enhance the truthfulness of the statements generated by these models. So their approach was firstly that they introduced the factual nucleus sampling algorithm, where this algorithm dynamically adapts the nucleus or the core set of probable next tokens as each sentence gets generated. It's a novel way to guide the generation process based on certain constraints. And furthermore, they pioneered a methodology known as factuality enhanced continued training. And this technique involves appending a prefix to sentences, ensuring each sentence stands alone as a factual statement. By introducing a statement or a sentence completion loss, they managed to correct any incorrect associations between the learned entities. This process effectively steers the language model to focus on predicting subsequent words in the sentence, emphasizing accuracy. The results are quite impressive, where with the mere act of prepending prefixes, the name entity-based errors reduced from 42.1% to 27.6%. This outperformed the 1.3 billion model with greedy decoding, and furthermore, they achieved a substantial improvement in factuality, especially in the entailment ratio, which saw a leap from 8.7% to 17.4%. On the chart, here we provide a comprehensive view of the results, and it clearly states that the performance enhancements achieved through various approaches and compares them against baseline models. In conclusion, this study underscores the significance of factuality in open-ended text generation and provides a viable methodologies to achieve it. The insights for this research were valuable, and they gave me some information that prepending to model inputs to the prompt was quite impressive and doable. So the next paper is the ever-evolving realm of language model enhancements with another influential work, this time by X. Wang and colleagues in 2023. This research revolves around the concept of providing reasoning abilities in language models. They wanted to take the existing chain of thought, well known as COT methods, greedy decoding, and refine it with an innovative strategy called self-consistency. And well, diving into their methodology, the idea was to apply a self-consistency approach across varied reasoning paths. The intuition behind this was very straightforward and very powerful. If the reasoning process is correct, there tends to be a larger level of agreement in the final answer as compared to when the reasoning is off track. And this is quite the same for human beings, and the authors point out that tried to think like a machine to get to this approach. And by aggregating the answers and marginalizing them over different sampled reasoning paths, the most consistent one is selected as the final answer, which we do all the time in democracy and stuff. So if you see the illustration, this is the visual representation of this method. And in the chain of thought method, the reasoning path is singular. However, with self-consistency, multiple reasoning paths are explored, and the model aggregates the most consistent answers, enhancing the accuracy of the outcome. Now, looking at the results, the methodology they proposed was not only simple, but also extremely efficient. Well, where they managed to achieve substantial improvements in the accuracy of reasoning tasks, but that's not all, and the self-consistency strategy also turned out to be invaluable for estimating uncertainties and refining the calibration of language model outputs, adding another layer of reliability. The chart here paints a vivid picture when you compare a reasoning accuracy of the self-consistency method with the traditional chain of thought. The enhancements are clear, where various models tested with self-consistency exhibit considerable improvements over their COT counterparts, which underscores the efficacy of the proposed methodology. In a nutshell, X-Wang et al.'s work has set a benchmark in refining the reasoning abilities of language models, and their techniques have served as a cornerstone in my research journey. Continuing on our exploration of advanced techniques in the world of language models, let's delve into another groundbreaking piece of research by Jay Liu and colleagues from 2023. Titled A Zero Resource Hallucination Prevention for Large Language Models, this work focuses on enhancing the reliability of these models, especially when they might make predictions based on unfounded or non-existent data, a phenomenon also termed as data hallucination. The crux of this research lies in introducing a pre-detection self-evaluation technique called self-familiarity, which is similar to self-consistency. But the essence of this technique is to assess how well the language model understands the input instruction, because if the model deems the input as unfamiliar, it chooses to withhold its response, thereby mitigating potential misinformation or hallucination. So the methodology is broken down into two steps, which for the first is concept extraction, where the model first pinpoints the core concept of the input instruction, ensuring that it's free from any stylistic influence which might skew the interpretation. And then concept explanation and familiarity measurement, where after identifying the core concept, the model generates an explanation for it. It then scores this, and based on how familiar the concept appears, creating a tangible measure for the model's understanding. The illustration provides a step-by-step walkthrough of the self-familiarity procedure, and as depicted, the process begins with extracting the primary concept from a query, such as what is the purpose of Operation Overload in World War II? And then the model then dives into the concept for explanation and computes a familiarity score. And based on this score, it makes a decision on whether to proceed with a response or refrain from answering. Highlighting the results, Liu and his team have successfully introduced a pre-detection mechanism that can identify and prevent potential hallucinations in responses. And all this is done under a zero resource setting, which is quite commendable. And if you see the table on the right, to provide a quantitative perspective, The table shows that the performance of various methods, including the introduced self-familiarity, in identifying hallucinatory instructions. And as you can see, self-familiarity outperforms other methods across different models, underscoring its effectiveness. And to conclude, this study by J. Luo et al. Adds a critical dimension to my research, emphasizing the importance of model reliability and the ways to ensure that the information dispensed is well grounded in real data. And as we proceed, we will further delve into works that have expanded on these foundational studies, enriching our understanding of this domain. Building on our exploration of techniques to improve the reliability of language models, let's look at another pivotal study from 2023 by P. Manacool and colleagues. The study, aptly titled Self-Check GPT, Zero Resource Black Box Hallucination Detection for Generative Large Language Models, offers an innovative approach to fact-checking models without relying on any external database. The primary aim of this research was to introduce a unique sampling-based methodology to fact-check the outputs of what are termed as black box models, where essentially these are models for which internal data or workings are not readily transparent or accessible. So the researchers leveraged the fact that if the model generates a hallucinated response or a response based on non-existent data, then stochastically generated samples from the sample model are likely to contradict this hallucinated statement. By comparing the initial response with multiple samples generated stochastically, they can assign a hallucination score, and this score indicates the likelihood of a statement being a hallucination based on its consistency with the samples. As you can see at the graph in the center, where for non-factual or hallucinated statements, Self-Check GPT's performance is commendable, easily surpassing other existing methods. And when it comes to factual sentences, to the graph on the right, which are essentially true statements, Self-Check GPT again stands out in its ability to correctly classify them. And the results, to sum up the outcomes, Self-Check GPT not only outperforms several gray box and black box baseline detection methods, but does so across different granularities, be it at the sentence or passage levels. And conclusively, P. Manacool's work brings forward an ingenious technique, solidifying the importance of ensuring model outputs are grounded in reality and factual accuracy. And the only limitation to this is that the computational power, since these stochastically generated responses will contradict it, you have to generate more to be effective. In this case, I believe to be at least 10 times, so it will take 10 times more time to generate, but still gets the responsibility it has. So based on these papers that I introduced, I aim to add two concepts to my research, which the first one is zero resource mitigation. And the focus here has shifted away from dependency on external databases or supplementary resources. The current trend emphasizes that amplifying these innate capabilities of the model to autonomously detect and rectify any hallucinations or inaccuracies. And also that my postdoc approach, where I fix after it has been generated, well, these are corrective measures applied post-output generation, and this means that after a model has already generated a response, Various methodologies are employed to assess and rectify any deviations from factual accuracies. And also prompting, where it's a fascinating area of exploration. Prompting is about refining the cues or triggers given to the model, and by optimizing these prompts, I aim to steer the model towards producing outputs that are more consistent with real world data and less prone to generating hallucinations. So for my future works, I tried to make a comprehensive framework where the goal is to design a holistic strategy. The proposed framework will not only assess the generated content's context, but will also discern the best corrective strategy and then efficiently apply it, ensuring reduced hallucinations. And then I will emphasize the consistency, where the emphasis here is on refining every aspect of the model, from curating a richer training data set, tweaking its architecture, to even introducing checks after content generation. And this multi-pronged approach aims to make the model's outputs more consistent and dependable. So moving forward, a significant chunk of research will be dedicated to identifying and rectifying false statements. This means ensuring the model's outputs not only avoid hallucinations, but are also in strict alignment with verified real-world facts. So in conclusion, while we stand on the shoulder of giants with the strides made in this field, the path ahead is ripe with our opportunities, and I venture into my research with these highlighted areas. So, thank you. That was all.